Hi everybody. I got a request for a quick little video on one of the homework problems, and I'm going to put it right here. I'm going to share my screen with you, and here we go. So the request was for this problem right here, which is the third problem in number 2 for section 1.1. So let's just jump right to here we go. So I did a quick thing here. The problem is, let me just go back to what the problem was. The problem was not the sum of the cubes, but the sum of the odd cubes. You see, we know we discussed the formula for the sum of the cubes, which it's gonna come up. But here I want the sum of the odd cubes, not one cube plus 3 cubed plus 4 cubed, and 1 cube plus 3 cubed plus 5 cubed plus so on. So again, not just the sum of the cubes, but the sum of the odd cubes. See, we mentioned here that the sum of the cubes is n times n plus 1 over 2 squared. That's cool. But this is not quite the same thing. It's similar, but not quite the same thing. And that's what makes it so tricky. So let's figure this out. So here's what I did. I did a little magic here. I said that I wrote number 2C because it's the third problem. It's the third part of question number 2. 1 cubed plus dot 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 plus 2n minus 1 cubed. That's what we're looking at. Hold on one second. All right, so here's what we do. So here's the problem: 1 cubed plus 3 cubed plus 5 cubed plus 2n minus 1 cubed. Now this is equal to 1 cubed plus 2 cubed plus 3 cubed all the way up to 2n cubed, which is all the numbers, 1, 2, 3, everything, minus the even numbers. In other words, if I just have the odd, here's the odd numbers. So the odd numbers is equal to all the numbers minus the even numbers. Let me just put this here just to make it a little more clear. I just want to type something here that, let's just put 2. So this is, and let me just put this also to make it a little more clear. So again, here we have the odd cubes. That's equal to all the cubes minus just the even cubes. Okay, so I have now this. Well, now all I'm going to do is one step I'm going to do first is on this second guy right here, I'm going to factor out an 8. So this here is equal to 8 times 1 cubed plus dot 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 plus n cubed. Because each one of these terms has a factor of 8. 2 to the, why 8? Because that's 2 to the third power. And I'm going to factor that out. So, in fact, I'm gonna rewrite this over here. I'm gonna write here 2 to the third power, so it's clear where I got it from. So you're gonna say, hey, where'd you get the 8 from? That's where it's from. Okay, and now this part is equal. We're gonna apply the formula that we did in the previous problem. So it's gonna be 2n times 2n plus 1 divided by 2, and that whole thing squared. And this guy over here, that's gonna be 8 times this formula, which is 8 times n plus 1 over 2 squared. Now, if you take these two big fractions and multiply them out and combine like terms, blah, 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 you will eventually get n squared times 2n squared plus 2n squared minus 1. N squared times 2n squared minus 1. And just for funsies, I want to show you, here we go. So here, if you can see what I have here, that's n squared times 2. What is it? It's sorry, that's a1 squared, right? N squared times 2a1 squared minus 1. So this is n squared times 2n squared minus 1. And this over here, what did I just do? Oh boy, I just messed everything up here. What did I just do here? What did I just do? I don't know what I just did. Don't I see what did I just do? Okay, let's see if I can fix that. I'm gonna pull this up. Okay, good. And over here, well, this is really just this is my n, and this here is 2n minus 1. So these are the odd numbers. That's this is once that's oh, um so that's just 1 cubed, that's 3 cubed, that's 5 cubed, that's you know, so on and so forth, 7 cubed, whatever. And over here I have the sum. So I'm adding B2 plus C1, I'm adding B3 plus C2, and so on and so forth. So that's where I'm getting all this from. But you notice that column C and column D come out to the exact same numbers, which is just, again, just a demonstration with a spreadsheet of the theorem that I just proved. When I do the stuff with the spreadsheet, that's really just demonstration. It's not really proof of anything, but it's nice to see little demonstrations that this stuff actually works. Anyway, that's it. It's been loads of fun. I enjoyed this thoroughly, and bye, everybody. See you next time.